In number 20, we're asked what the period and amplitude of y equal 5 sine 7x is. So the amplitude is given by the number in front. So we have our amplitude is 5. And the period is whatever number is multiplying x, in this case 7, and that would be 2 pi divided by that number, 2 pi divided by 7. In number 21, we want the period, amplitude, and phase shift of this function. So let's start with the phase shift. In order to get the phase shift, we have to factor out the 5 from parentheses. So let's do that first. So y is equal to 3 cosine. Let's pull out that 5. And so here we have x minus pi over, and then the denominator will be 4 times 5, or 20. You can see that that's correct if you multiply back. We have 5x, and then we have 5 pi over 20, which simplifies to, reduces to pi over 4. Okay, so now we have the amplitude is right here. For the period, we use this number. In the formula, we divide 2 pi by that number, 2 pi divided by 5 for the period. And for the phase shift, we use this number, we actually, with the opposite sign. So the phase shift is plus pi over 20. That means pi over 20 to the right. In number 22, we want to do this graph. So let me first factor out the 2 so that we'll know the phase shift. So that would be x minus pi over 2. So we have a phase shift of pi over 2, and that's where we'll begin our graph. We have the period will come from the number multiplying x. We'll use that number in the denominator. So 2 pi over 2, or we have a period of pi. And here's our amplitude. So we're going to use all those in our graph. Now, we're going to start our graph at the phase shift, at pi over 2. So the phase shift is positive, so we're going to the right. Pi over 2 to the right, so let's say this is pi over 2 right here. And we'll draw our basic cosine graph. All right, let me divide the axis into 4 equal parts. That'll help me draw my graph. So for the cosine graph, we'll intersect the axis after 1/4 of a full period, and then it goes down in the middle. All right, again intersects and up. So there's the basic cosine shape. And we want to put in these intervals. This will be, we are graphing 1 period. So this is a cosine graph for 1 period. Okay. Each interval here is a 1/4 period. So we want to find these intervals and mark them on our graph. So the first one will come at pi over 2 plus a 1/4 period. Well, a period is pi. A 1/4 period, in that case, will be 1/4 pi, or pi over 4. So we're going to keep on adding pi over 4 to get to the next interval. All right, so we're starting at pi over 2, and next we have pi over 2 plus pi over 4. Pi over 2, that's 2 pi over 4 plus pi over 4. Just getting a common denominator, so that's 3 pi over 4. So this interval comes at 3 pi over 4. And let's add another pi over 4 here, and we have 4 pi over 4. We'll reduce that later. And here we have 5 pi over 4. We keep on adding. And finally, the last interval ends at 6 pi over 4. So let's reduce this. This is actually equal to pi. And let's see, and the last one reduces to 3 pi over 2. So if we want to mark this point, starting with this point is at pi over 2, comma 3, 3 because of the amplitude. Here we have 3, and at the bottom here we have minus 3 because of that amplitude. All right, so this point is at pi minus 3. And this one right here, 3 pi over 2, comma 3. Okay. Here, of course, we have y-intercept 0, y-intercept, y-coordinate 0, y-coordinate 0. All right, so we have our 1, 2, 3, 4, 5 points marked on the graph. In number 23, we want to know the domain and range of the following inverse trig functions. So first for arcsine, the x values are between minus 1 and 1, and the y values between minus pi over 2 and pi over 2. Now arc cosine, x values again between minus 1 and 1, and y values are between 0 and pi. For arctan, the x values are between minus infinity and infinity, and the y values are between minus pi over 2 and pi over 2. This time we don't include the minus pi over 2 and we don't include the pi over 2. You see, here for arcsine we do, here we do not. In 24 we want to find these values. Let's start with the first one. Okay, so we have the sine of arc cosine minus 2 over 3. So let's call this angle theta. Theta is an angle whose cosine is minus 2 over 3. And we know that that arc cosine has a range between 0 and pi. So since the cosine value is negative, it must be in quadrant 2. Between 0 and pi, that's quadrant 1, quadrant 2. So in our case, theta must be in quadrant 2 because the cosine value is negative. All right, so for these problems, we draw a triangle. I'm going to put reference theta in here because it's in quadrant 2. And we know cosine is this, minus 2 over 3, so I'm going to put a 2 for the adjacent and the 3 for the hypotenuse. And here I have the square root of 9 minus 4, or square root 5. We want the sine of this value. The sine of this value, the sine of theta, is square root 5 over 3. And it's positive because theta is in quadrant 2. All right, let's look at this one, secant. Okay, so now we're going to call this theta again. I'm going to use theta over again. Now, theta has a positive tangent value. The tangent value is 5. So that means theta is in quadrant 1. Theta will be in quadrant 1 or quadrant 4, because remember the range is between minus pi over 2 and pi over 2 for arctan. So we have quadrant 1. All right, let's draw a triangle, and we'll put theta in our triangle. Theta has tangent 5 over 1, opposite adjacent, and the third side is square root 1 squared plus 5 squared. That would be square root 1 squared plus 5 squared. That would be square root 26. And now we want to know the secant. Secant theta. Secant is 1 over cosine. So that would be hypotenuse over adjacent. So that would be square root 26 over 1. And it's positive because we're in quadrant 1. All right, let's look at arctan. All right, so arctan is an angle, and it's in this, if this is angle theta, let's say, theta must be in quadrant 4. In fact, theta must be between, all arctangent values are between pi over 2 and minus pi over 2. So this one must be between 0 and minus pi over 2. That is in quadrant 4 because of this negative value. So the tangent of 30 degrees is 1 over the square root of 3. So we're looking at reference 30 between these two values. This is minus 90 degrees. If I change over to degrees. So theta must be equal to minus 30 degrees. Theta is between 0 and minus 90. And tangent theta is negative 1 over square root 3. So that's it, minus 30 degrees. Here we want to solve some trig equations. I'm going to solve them for all theta. So I just crossed off that little phrase there. So here we have, in the first one, sine 2 theta equal cosine theta. Let's open this up. Sine 2 theta is 2 sine theta cos theta. Okay, using our trig identity. Let's set this equal to 0, because we're always setting equal to 0 and factoring. Now I see we could factor out cosine theta, so let's do that. So here we have two equations, cosine theta equals 0, and 2 sine theta minus 1 equals 0, or solve for sine theta, and we have sine theta is equal to 1/2. All right, cosine theta equals 0. If we look at the cosine curve, it's 0 in two places. That's 90 and 270. So I'm going to write down theta equal 90, theta equal 270. Sine theta equal 1/2, I have theta equal 30. That's our quadrant 1 solution. And also theta is equal to 150. In quadrant 2, sine is positive, so I have a quadrant 1 and a quadrant 2 solution. And now for the general solution, add on n360. And then we have all the possible theta values. Our next equation is already equal to 0 on the right-hand side, so we're just going to factor. You might want to factor 2x squared minus x minus 1 equals 0. Let's see what we get when we factor this. We have 2x, x for first times first, and then we want to get a minus x in the middle, so plus 1 times minus 1, just make sure you have the right middle term. Minus 2x plus x gives us a minus x in the middle term. So if we solve this one, we have x equal minus 1/2. And here if we solve this one, we have x equal 1, setting each equal to 0. So go back to sine theta. So we have sine theta is equal to minus 1/2. And we have sine theta is equal to 1. Sine theta equal minus a half. Sine is negative in quadrant 3 and 4. So we're going to have a 30-degree reference, quadrant 3 and 4. So for quadrant 3, we have theta is equal to 180 plus 30, or 210. For quadrant 4, theta is equal to 360 minus 30, or 330. Here sine theta is equal to 1. Remember the sine graph, it looks like this. So sine theta equals 1 right here at 90 degrees. And just add on the n360, and that's it. In number 25, we'll start by setting this equal to 0. So let's put this one on the other side and this one on the other side. So we have 0 equal to cos squared theta. And here we have minus sine theta minus 1. And we want to change everything over to either sine or cosine. So we'll change over to sine, put 1 minus sine squared theta right here. And we're going to start just simplifying this a little bit. 2 minus 2 sine squared theta minus sine theta minus 1. Combine these. And we have 1 minus 2 sine squared theta minus sine theta. All right, let's bring over everything to the other side so that this sine squared will be positive. So we have 2 sine squared theta plus sine theta, and bring this over as minus 1 equals 0. And now we have to factor this. All right, so this is, we'll factor like 2x squared plus x minus 1 equals 0. Let's factor that. 2xx. And we have plus 1 here and a minus 1 here. So you get a plus x in the middle, 2x minus x. We do get the plus x. Solve this, and we have x equal a half. And here we have x equal minus 1. So in other words, we want sine theta equal half, or sine theta equal minus 1. Sine theta equal minus 1 at 270. And positive 1, sine theta equals positive 1/2 if theta is 30, or if theta is quadrant 2, 150. And then just tack on n360.